Okay, welcome to this session, which is about installing packages. And we will see how to install Python packages with pip in a general way, and also understand limitations of installing packages outside a virtual environment, which will be the next session. So there are two ways. That is this so-called local installation, which will make the package you install available as long as you load the same version of Python again. So that means that you can use the package next time you load this module. So it will be general. So it's about the same as having the package already inside the Python module. A little bit more details in how this works in a minute. The other way is to use isolated environments, and where you create virtual or isolated environments where you can have certain packages only there, and you will not have any interaction with other projects that you are using. So this is very nice in some cases. More about this in the next session. And then here you have virtual environments with local, provided by Python itself. You can also use Conda environments where you use the Conda tool. So if you're working with a project and you want reproducibility, it might be better to actually create these isolated environments. But there are also some use cases where these general packages is quite nice. And that is if it is missing in the loaded Python module, and that would not be specific for a research project. So it could be something that you will use for everything you do. And that the version is not very important on that package, then installing as a general package will be the case for you. And a good thing is also that if you are using virtual environments, then you can include these packages that you installed as well. You can include them in your virtual environment. So how does this work? Well, the typical workflow is that you first load the Python module with a correct version. And of course, you learned that this is a bit different in different clusters. Then you can check that the right Python is used with these commands, like which Python or which Python 3. I can make this a little bit bigger. Yes. And you can also double check the version so you are really sure. And then you use this command pip install -- user and the package name and also perhaps a version. And to be sure, well, you can check also that you can check the pip version, but the pip should be included in this module. But to be really sure, then you can run python-m pip and then the install command like this. You can also, so to say, pin versions. So you can decide to, okay, I want NumPy and I want exactly this version. And then you can note this double equal sign. You can also use this, which would mean that, okay, I am all right with NumPy version above 1.22. So this is excluding 122, but it includes 123 and up. You can read more in this link, where you can also see that you can have an inclusive ordered comparison clause as well with this, where you include both equal sign and the less than or bigger than sign. Oh yeah. Yes. All right. So if not pinned, you will get the latest version compatible with the Python version you are using, and possibly also compatible with other packages, because some packages will depend on each other, and sometimes it's really it's important that it is a quite narrow range of versions. Otherwise, the package environment will not work together. I mean that different packages will not work together. So this could be, yeah, sometimes it can take some time to actually find out a good environment for you with all the packages working together. But in the modules, in a Python module or in a bundle module that we have on some places, like the SciPy bundle, these packages go together. They are compatible with each other. So that's quite good to know. So what can go wrong? That is when you try to install a version that does not exist or does not comply with the existing environment. So this might be a bad example. I want the NumPy 0.1, but yeah, this is not possible. So we get this error that it should be one of these versions. And then you can try this out, and maybe you need some trial and error to find something that actually works together with the rest of all the packages. Yes. So the packages that you install this way typically end up in your home folder in a directory called .local, and in the subfolder lib and python 3 something. So for instance, if you install a package with Python version 3.11.5, it will go into Python 3.11 here. But this will also be the case for 3.11.8. That will also go into this 3.11. So that means if you install something with 3.11.5, if you later use 3.11.8 Python, it will still find this package that you installed by 3.11.5. And then you can also check your installed packages and dependencies with this piplist user. So I can just show for Tetalit. I'm logged in here. And so a nice command that I use a lot is the bash command history. this. And on TetaLit, I see that I quite often load this. So module load and this, and in this case, the SciPy bundle. But I want to try first this one. So I copy paste this one. And let's see if it's loaded. Yes, we have Python and so on. First, we can actually look here. Where are we here? Pip list user, see if I have installed anything. Well, we can first try pip list. So that actually will show all the packages inside this Python module. So we see not very much, but we have pip at least. That's nice. Now let's install Xarray here. So we do pip install user Xarray. And we see many things are happening. We see, for instance, that it tries to install 6 as well, NumPy, actually pandas. And now this is ready. We can ignore this warning. So now we can check. I will do up arrow to look at my last commands. So user. Now we see that, okay, Xarray we installed, but also NumPy and pandas are here. We can also see, well, will it end up here? We go here, cd dot local, and I do a tab complete. So pressing tab key will give me some suggestions. Local, and it was lib. We can check here what we have here. We have Python 3.11, yes. And going into this one, Python 3.11 and site packages. That's the only directory here as well, actually. So looking here, you see some folders here with our installations. Now I will just empty this to try another way to make an installation. So we see that we have this one. I will remove everything. And this is not anything you have to do. It's just to clear things out. So let's see here. Yes, now we have no Python 3.11. What I will try to do now is to use the SciPy library as well, or SciPy module. So I do a purge, and I will go up. I will actually use the history, and I want this one. Yes, look what we hear. Oh, sorry. SciPy bundle. It's here. And we also get a Python version, and that's 3.11.5. Yes. And we can see here, pip list. We actually see here that, yes, we have this 6. We also have already pandas. Yes. And we also have NumPy. There it is, yes. But we are lacking X-array. Yeah, please note that we have it in alphabetical order here. So X-array is not here. So let's do this again. I will go back here and do this pip install user X-array. And we see here that we have quite a lot requirements already satisfied in some cases here. But successfully install X-array. Now we can see if we do a pip list user, only X-array was used or installed. So from this we can see that it's evident that some packages have dependencies. So X-array also installs NumPy and pandas. But if you have something loaded already, when we actually already have NumPy and pandas, then it's already available, and those will be used and not installed again. So these local installations or user installations, they complement what you already have, basically. So yeah, once again, it's good for general packages that you use often. If it's not already in one of the bundles or the Python module that you already loaded. Yes. So that's about it. And see you next session where we go more into details in how to use isolated environments.